everybody, my name is Jay Gordon. Welcome to the Azure Cosmos DB Global User Group. What do? We try to get together at least once a month on Tuesdays, not every second Tuesday of the month. And we do our best to kind of bring people in from our community to have conversations with us about different parts of how they're using and implementing Azure Cosmos DB. We've got a great subject today. I'm going to talk a little bit more about what we're going to get into. This week's show is called Attaching a Graph Visualization Layer to Cosmos DB. And so we're going to learn how that works. I got a great guest to help me through that. But before I bring our guest in, we always want to make sure that we do a little bit with our Reactor partners to make sure that everybody's up to speed with how this works and how they can have a great time being part of this. And to help me do that, I have our partner from the Reactor, Askia. Hi, how are you today?
Good. How you doing, Jay? Good to see you again.
Great to see you. Thank you for helping us out. We love how the Reactor brings people in. If you don't know what the Reactor is, do you want to just give everybody a quick rundown?
Yeah, we are basically like an event space. We work with nonprofits, we work with developers, we work with startups. We basically give them a platform, a place to present their information. So lots of meetup groups and things like that. We basically just try to be an outreach for the community, tech community, and yeah, it's been going good.
And I think you do a great job. I've gotten so much from being part of Reactor events. I've run some here in New York City. It's great. So I know you have a little housekeeping to do for us, and it's a very important subject. Why don't you go ahead and give us a little rundown?
All right. Well, thank you. Yeah, basically at Microsoft here, we seek to provide a respectful environment for both our audience and our presenters. So we encourage engagement in the chat, but we ask that you please be mindful of your commentary, remain professional, and please remain on topic. We will share useful links throughout the chat, and the session will be recorded and will be available on demand within about 24 to 48 hours on the Microsoft Reactor YouTube channel. And that will bring us to today's session. Slide. So I will present it back to Jay and our guest for today.
Great. Well, thank you very much. Appreciate you giving everybody a quick rundown. I know that we'll see you at the bottom of the show. Looking forward to helping our guests, or I should say our viewers, learn about what they can do next, how they can be part, all the great things with the Reactor. So we'll see you at the end. So great. We are getting closer and closer to talking with our guest for today. But I just wanted to set some context. So the Azure Cosmos DB property graph model, which is what we're going to be talking about today, offers versatile applications spanning from business intelligence analytics to fraud prevention. Although visualizing graph data holds significant power, some effective human decision-making still remains extremely crucial. So while visualization is often the key, presenting large volumes of graph data demands careful user experience design. So today, we'll be exploring which applications benefit from graph visualization, techniques to avoid for user-friendly exploration, and the challenge of representing changing graph data over time. And we're going to be working to avoid overwhelming data, excessive properties, and text-heavy labeling. So with all that, and that felt like a mouthful, I want to bring in the person that's going to help me learn more and help you learn more. And that person is from Cambridge Intelligence. It is Corey Lanham. Hi, how are you today?
I'm doing great, Jay. Thanks for having me on. I'm excited to be able to share some of these concepts with you.
Great. So one of the things I wanted to ask you first, are we going to be focusing on the Gremlin API when we're doing this, or are we going to use another API?
Yeah, so we are going to use the Gremlin API, but I talk a little bit about halfway through that you don't necessarily have to. There are definitely situations where you might have graph data, but it makes more sense to use a standard SQL API.
Great. So we know a little bit about what we're going to be talking about, but I always want to learn a little bit about the person who's going to be doing the talking. So, Corey, why don't you tell me a little bit about what you do and how you do it and where you do it?
Sure. So I actually have an introduction slide. So if we can pull up the slides there, I'll give you a very brief introduction because I want to make it more about the subject than it is about me personally. But
Sure.
my name is Corey Lanham. I've been doing graph-related stuff for 23 years now. And I wrote a book on the subject called Visualizing Graph Data in 2016. I'm not here to pitch my book. In fact, I would recommend you don't buy it because it's 7 years old at this point and the technology has changed. I probably need to do a version 2, but I'm not quite there yet. And I work for a company called Cambridge Intelligence. And what we do is we create graph user interfaces. We have components for our customers who want to build a graph interface for their applications and connect to their data sources. And it's designed to be sort of agnostic. So anything, like you said, from fraud prevention to cybersecurity to defense kind of related data.
Very cool. So I know you've got a bunch to show us today, and I want to give you that space to do it. But I also want to remind the people who are viewing in the background, or I should say, who are watching us today, you may have questions. And if you do, well, leave them in the chat. We'll address them as soon as we can. We want to hear from you. If you would like to see any of our Azure Cosmos DB live TV shows, here's the URL right here below us. You can catch up on all the old episodes. You can see our whole YouTube channel with so many hours of videos that you can watch. And the last thing that I want to remind you is that this meetup is about you, our viewers, our members, and we want you to be part. There's an intake form that you can fill out, and you can do a presentation just like Corey is today. We'd love to hear from you, but for right now, we want to hear from Corey. So, Corey, why don't you go ahead and give us your presentation? We'll sit back and give you the space to do so.
Okay, sounds great. Thank you. So one of the things I want to talk about is how to create a useful graph interface when you're working with a property graph data. Because I find that a lot of people that I work with get really excited by the concepts of graphs and all of the implications and the applications for them throughout their entire data set. And that is really exciting. I get excited by it too. But oftentimes, how to present this to an end user, a business user who has to make decisions based on it, is often an afterthought. So you can have the greatest data model in the world. You can have a great query engine that gives you phenomenal performance and is really intuitive. But if you don't actually show that to somebody who doesn't know Gremlin or who doesn't know what a property graph model is, then it's not going to be that useful to them. So one of the things that we focus on as a company, and I focus on personally, is how do we actually present graph data to an end user to enable useful decisions? Because at the end of the day, that's really all what we want to do is we want to collect and store and analyze and query and visualize data such that it actually helps us on our day-to-day jobs, whatever those happen to be. So the first thing I want to mention, though, is that oftentimes the distinction between what a graph database is and a graph project is a little bit blurry, and they aren't really the same thing. You can definitely have applications where I want to show something as a graph. I want to show nodes and links and allow a user to think about the data and work with it that way, but not have graph database on the back end. And similarly, in the opposite direction, I may have a graph database because I really benefit from storing and analyzing the data that way. But I don't want to show the user that I'm using that. I just want to give them answers in a different format. So let me show you a couple of examples where you might want to use one and not the other. So I like this because if you think about a maze, a traditional children's pen and paper maze, the reason that you get excited by that or that it's a challenge is that you have to kind of work your way through from one point on the maze to the other. And you can't just at a glance see what direction you have to go. You kind of have to draw your pen down it before you realize whether something's a dead end or not. And I'd liken that to the difference between a graph showing directions. So if you think about like an old school road atlas before everybody had GPSs on their phones, there would often be like a table or a diagram in the back that said, if you're going to drive from Toronto to Richmond, here's the various cities that you have to go through, and here's the drive time between them. That's a graph right there. You know, the cities are connected via their highways, and here's how you navigate between them. But we don't need that anymore. Everybody just has this turn right at the next intersection. They don't even really know where they're going. They just let the computer figure out where to go. And most people prefer that. So there are definitely applications where I want to have my data as a graph. This city or this intersection is connected to this intersection via a road that has this speed limit. And, you know, the graph engine can then calculate what's the quickest way to get from one point to another. But the user doesn't want to know that. They don't want to see, here's all the other places you could have gone from Toronto or the other routes that you could have taken to get to Richmond. They just want turn-by-turn directions. So a graph model makes a lot of sense in this case, but a visualization is actually counterproductive. It doesn't help the user accomplish their goal. Another example I like to use here is the recommendation engines. So people are, for good reason, using graph models a lot in sort of understanding, I'm like other buyers in these respects, and these other buyers have bought these following products. Therefore, I might be interested in those. And, you know, virtually every e-commerce merchant does something like this. But the user doesn't want to see, you know, I'm linked to these other people because they have these various properties in common. They just want to see what other things might I be interested in and what might I be interested in buying. So another example where if you have the answer and you know what the question is, then just presenting that answer is probably way better than actually having an interactive graph interface. Now we can do similarly in the opposite direction. So I'm going to work through an example today that I built a brand new application from scratch on top of some data that I downloaded just like a week ago. And I built it and modeled it as a graph. And then I'll show you how we can create an interactive and interesting UI around it. But to be honest, the data itself is not that graphy. It doesn't have tons of different node types and link types and property types and things like that. In this case, what I did was I went to the US Federal Elections Commission, which captures all the political donations to various candidates for federal elections like Congress and president, things like that. Now, if you think about that data, it is a graph. I've got an organization here on the right that can contribute to multiple different candidates. And then I've got a candidate who gets contributions from multiple different organizations. And anytime you have that sort of many-to-many relationship, that lends itself very well to being thought about as a graph. And you'll see why once we get into some of these examples here. But if I actually think about what that data really looks like, I've got an organization, I've got the value of the amount that was given, date, time that it was given on, the candidate. The candidate probably has some properties like the state that they represent or things like that. That's just a table. It's just a single table with a bunch of different columns. So in this example, I actually did load it in as a fairly simple property graph into the Gremlin API, and I'll show you how I both loaded it in and got queries from it. But it might have been more straightforward to just do it in this case using the SQL interface. And so you don't necessarily, even if you want to have that graph kind of view, nodes and links connected to one another, if you've just got one or two tables, then SQL makes a lot more sense. And that also allows you to show the data in other ways other than graph visualizations like pie charts and bar charts and, you know, your more traditional things, which is much more difficult to do if you're storing it as a graph. So the graph model, and in this case, in Azure Cosmos DB, the Gremlin interface, makes a lot of sense when you have really complex graph structure, lots of different node types and entity types, and each one has different properties, and they're all connected to one another via different types of relationships. But oftentimes your data is not that complex, and you're not going to present it to the user in that complex a way. So, you know, use something you're familiar with. In this case, maybe this SQL interface. So when should I actually use a graph interface? I talked about when you might not want to use it, which is when you know what the questions are that the user is going to ask and you know how to generate those answers and give them to them. So basically, it's all the opposite of that. It's when I don't know what the question is that the user is going to ask, or be looking at the data might raise other questions that they want to explore in the context of the visualization, or if they want to uncover patterns in the data, not just necessarily the one answer. And by looking at data this way in a graph, certain things stand out visually that spark a user's interest to say, oh, I want to drill into that in a little bit more detail, or I want to better understand why that pattern's there, or what other things might that item that I'm looking at be connected to or be relevant in this context. So in the case that I'm going to show you today, where I have data about political candidates and donations to those candidates' campaigns, you might have some interesting things. Like I found a organization that donated primarily to Republicans, but to one Democrat. Why? That's something that, what else? What's the timing of those? Who else is that one Democrat getting money from that might be relevant for why they are getting donations from somebody who primarily donates to Republicans? Those types of questions and the ability to explore through the graph and ask those things where you don't know in advance what they are is a great application for graph, as I hope you'll see when I show you this example. So a few best practices here of things that you should think about when you're building a graph UI, and you'll see when we get to the demo that I've built using some of those. And the first one is really the most important, I think, which is don't show all of your data, all of your work to the user all at the same time. And that's really important because I can't count the number of times I've talked to my customers, my users who are building applications, and they say, well, the user wants to see the whole graph. They want to get the big zoomed out picture of all my data. And the answer is that's what they may want, but once they actually witness that, they probably don't want it. So you should safely ignore what your users are asking for at that point. Because, the data that I loaded in is only 12,000 records. It's not that big because I wanted to have a more manageable size to kind of show you some various applications. But in most real world applications, it's, hundreds of millions of records, and each one represents an individual node. And you can't put that much on the screen all at once. You can't realistically expect the user to know what it is they're looking at, or be able to eventually just run out of pixels for what I can realistically display to somebody. And there's no amount of interactivity or laying out that makes that useful. So instead of basically just shoving an entire data set onto the screen at once, what I recommend is to start from a query. Say, I'm interested in this subsection of the data, people who match this pattern, or nodes which were in this happened in this time frame, and then allow the user to expand out from there. So I'll show you that too. And the other big one that I suggest avoiding, which is kind of a pitfall I see a lot of people do, is they get into this graph model and then they think about everything as nodes and links. So I made up a term called over notification, which really just means I'm thinking about things that should be properties as nodes. So for example, if I have myself, Corey Lanham, as a node, I am a person. I have a first name and a last name. And the temptation for people who are just getting excited by this graph model is to have a has first name relationship, and then have another node that says Corey, and has last name relationship to another node that says Lanham. Well, there's no situation in which that level of granularity actually makes sense. I don't want to see myself linked to other people who have the same. I mean, maybe there are some applications if I'm going to a giant conference of Corys, but in most cases, there's no reason why I have anything in common with other people who just happen to share my first name. So realistically, that's better stored as a property and presented to the user as a property of the data. And then you can decide how to label it. So, the label on the node might be first name space last name, for example.
Hey, Corey, can
Yes,
I
go ahead.
pop in with a question from one of our viewers?
Sure.
So Sam asks, is the statement don't show all your data all the time to all users apply to locator variables, while accessing an API access does not apply to GPS hardware? I'm not sure about that. But
I think I understand that question, but feel free to rephrase it if I'm not answering what you asked. So in the example that I'm showing you, I'm bringing all of the data into memory and then allowing the user to interact with it from there, to filter things out, to zoom in on certain things and that sort of thing. But I'm doing that because I only have 12,000 records to work from, and it's pretty easy to store that in memory. In a more realistic scenario, you want to keep all of that on the server side and only bring in the data that the user specifically asked for into the browser to allow the user to interact with. And then you can always make subsequent calls, queries back to my server to get the additional data. So I both mean don't physically draw it on the screen all at the same time, but I also mean don't store it in memory, because eventually you run out of memory too.
Great, thank you.
Sure.
No other questions right now, but just reminding everyone, if you have them, please share them in the chat. Go for your, what's next, please.
Great. So I'm halfway through the don'ts here, but the next one is that you really do want to have this interactivity. So what you don't want to do is you don't want to present a static image that the user can't interact with. That's great for if you're putting a small graph in the newspaper and you're printing it on the page. Of course, that's what you have to do. But by having it be a static image, you don't allow the user to get more detail about a specific item. If you want them to see some properties of a node, you have to write them all on the node all at the same time. And that creates a lot of visual clutter and makes it difficult to understand what's going on. So if you do look at graphs that are drawn, for example, in the newspaper, they have to put all of that detail in there in advance, and it can make them quite cluttered. When we're doing that in software, we don't have to. And then the last don't is to ignore date time values. So when we first look at the graph that I'm going to show you here in a minute, that's exactly what I do. You know, a candidate donates, or an organization donates to a candidate, but we don't have any sense of when that happened, or whether it was once or multiple times spread across years or all at the same time. And that's really relevant information that the traditional way of drawing graphs doesn't take advantage of. So there are many different options for showing how graphs change over time or how my data is changing over time. And I'll walk through a couple of examples where how you can do that. So over on the do side, I talked about interactivity already. I think that's a critical one. Labels and colors, I think it's easy to go nuts with that. Labels in general, I think, should be used as sparingly as possible. Just show me enough to identify what this node represents, but don't write a whole paragraph around what this is, what that node is. And then the same with links, even more so. It's almost never that I choose to draw labels on links that represent that type of relationship, because there are so many more links on a graph than a node that it makes a lot more sense to have the link color represent the type and then have some sort of legend somewhere else. And then do group nodes together. So for example, when I talked earlier about having, tens of thousands of items, then, maybe I can say all items that share a common property can be shown as a group and drill down into that detail of that group when the user asks for it, to simplify or kind of summarize the chart. So I'll show you an example of that too. And then I talked about using the text sparingly so that we're not over labeling things. All right. So now let's get into the actual example that I built for you today. So for those of you who are outside of the United States, I think the data is still going to make sense, but it is a little bit focused on sort of American elections. Now, the Federal Elections Commission collects data around every political donation. They do this for individuals and for organizations that donate to political candidates' campaigns. And they actually make all of that data available. Now, the individual one was way too large for what I'm trying to show you today. I wanted to keep it a bit more manageable. So I went with the organizational donations. So these are companies or unions or activist groups that donate to certain candidates' campaigns. And they allow you to download as much or as little of that as you want and do whatever you want with it. So it's a perfect application to kind of show some techniques around how can I make a valuable web application to explore this data as a graph. Because as I mentioned before, the donors themselves are nodes, the candidates themselves are nodes, and then that donation is a link between that donor and that candidate, which has a value and a date. So what I did in this case was I downloaded the bulk data from the current election cycle. So we're quite early in the 2023-2024 cycle, which is why there isn't that much data yet. And you'll see the date ranges of what I have. Now, when you download it from the FEC, you get a CSV file. So the first thing I needed to do was to get that into Azure Cosmos DB. So the way I chose to do that was to create a brand new instance and set it up with the Gremlin interface. And then I wrote just a little bit of JavaScript in Node.js to go through each entry in this CSV file and create new nodes and links over on in Azure Cosmos DB. So you can see an example of the Gremlin there. For every row, I'm creating a candidate vertex. I'm giving it the property. The CSV doesn't have field labels. That's just how the Federal Elections Commission does it. So I just have to say field 1, field 2, and field 3. So for every row, I'm creating new nodes and creating a new edge between them, basically. So I know that Azure Cosmos DB, the Gremlin interface, has some options for bulk for bulk loading. I chose not to use those in this case just to make it a bit more straightforward what I was doing. If you were loading in 10 times, 20 times as much data as I was, then that would make a lot more sense and be more performant. And then so here's how the application works, basically. The user's going to interact with the actual web browser. They're going to look at the data that they're seeing in the graph. They're going to be clicking on things. They're going to be doing searches and stuff like that. They're sending that data into the browser, and then the browser is turning that into a query around a node or a link. So when I say find Chris Pappas, the browser's saying, okay, I know what that means. That means you're looking for a candidate named Chris Pappas. Now, the way I chose to do this, there's a bunch of different architectures that would work, is the browser, the application's hosted with Node.js. The browser is then saying, here's the name of what the user is looking for, but I'm not actually having the browser create the Gremlin, because that opens yourself up to some security flaws where, I could just open up the JavaScript console and start typing in my own Gremlin, and potentially I'll get into all kinds of trouble there. So the only thing you can do is you can give it a name of what the user is searching for, and then it's the server side of my application that's actually turning that into the AJAX call that says, go find, and you can read the Gremlin here, the candidate who has the name Chris Pappas that I put in, and get the results out. Cosmos DB is going to return that as JSON. The server doesn't do anything with that JSON. It just passes it back to the browser, which then translates it into the node and link format for my visualization, so that the user doesn't actually see the results. They wouldn't know how to interpret JSON anyway, but they see what that looks like in terms of getting nodes and links getting added to the graph. So that's kind of the flow of how we get from the user down to the graph database and then back. And then a couple of notes about the styling too. So I think the styling can be really important, because you can make it very intuitive or you can make it very unintuitive. So making good decisions here about how do I actually represent what it is I'm trying to show in the graph to the end user. So the way I chose to do this is to have a candidate node be sort of a complex representation which shows their party as an icon. So I have the donkey or the elephant, the name of that candidate and the state that they represent. And then they're colored by their party as well. So red nodes are Republicans, blue nodes are Democrats, and I have a gray color for anybody else. Now, the organization nodes, I don't have that detail. In fact, the FEC really only gives me the name of the organization and a couple of small details. So in this case, I render the node differently. I just draw them as a more basic node with their label being the name of the organization. Now, one thing I did here to help out is that when I load the data into the graph, I check to see if an organization has donated solely to one party or the other. There's a lot of these cases once I started drilling into the data. There are organizations that donate only to Republicans or only to Democrats. So it makes sense to color them that way. This is a Democratic-funded political action committee, for example. So, even though that's not in the data, it's pretty easy to figure out by looking at what they're linked to. And then the last thing I have in the styling here is that the link width is based on the value, because you might be less concerned with something that's a $5 transaction versus something that's $5,000. So if you think about the value as being or the link as being like a pipe, the wider the pipe, the more money can flow through it. So link width is kind of an intuitive way to represent that. All right, so now before I continue with the slides, let's show you what this looks like. Now, I know I just got done showing you or saying don't load all of the data in at once, but that's exactly what I did here. And I'll explain why is because, first of all, it's only 12,000 records, so it's not completely overwhelming. But in this case, I think it makes sense to better understand the structure of what we're looking at. So let me walk you through this a little bit. I'll just zoom in on an example here. I have a particular member of Congress here, and I have all of the organizations that have donated to her campaign. And, she's linked to various other things. So these other organizations have donated to her in addition to other candidates and stuff. But I also have all of these kind of separate clusters around the main cluster. And the reason for that is there's a lot, especially since we're early in the cycle, there's a lot of candidates who don't have any connection to the broader ecosystem. They only have organizations which donate to them and nobody else. So they're not linked to anything else on the chart. So in this case, there might be situations where we just want to ignore those. I'm not really interested in, this person who seems to really only be getting campaign donations from their own political action committees. So there's not much going on right there. And then if we look at the main structure, this sort of bit in the middle here, you can kind of see some patterns, even at this level, without even, zooming in and looking at the detail. I've got this bit here, which seems to be more of the Democrat ecosystem. And then this bit up here on the right, and then at the top, which is more of the Republican ecosystem, although there's definitely some interconnections between the two. And that's pretty interesting. If I zoom in on one of these, we'll pick, this one. There's an organization called CivTech, which is based in New York. You can see I put a tooltip on there to show me where they are, which is, donating only to Democratic candidates. And, if I click on it, I'm sending everything else to the background to allow the user to better understand what it is that they're looking at. And I can see, here are the candidates that person's donated to. I've got some yellow. I left an organization yellow if they donate to both Democrats and Republicans. So here's an interesting one, for example. I don't have any idea what IAO Property Holdings is, but you can see that it's given money to a mix. Seems to be primarily Democrats, but to Republicans as well. So I might be interested in then drilling into a bit more detail and seeing, what's unique about these two, or who is this company and what are they doing? One thing I found really fascinating with this data was, I've got this organization up here, which is linked to, forgive me if you're not American or you don't follow politics, but somebody who's linked to Elizabeth Warren and Kevin McCarthy, which are basically two polar opposites in terms of their political ideology. So I would be really curious what the agenda is of an organization that's donating to both of those. And then that stands out pretty clearly. I can see that this is holding together two kind of extreme parts of the graph on its own. And I zoom in and it's MailChimp. I don't know why MailChimp is so politically effusive with its donations, but there might be something worthy of further investigation going on there. So there is some value that you get out of looking at all of the data all at once. And then you can see down here at the bottom that I have a time bar as well, which is showing me when they occurred. And, it goes up through the end of June and from the beginning of the year. And you can see that they kind of, because we're at the beginning of the cycle, these donations are becoming more prevalent toward the end of that cycle, toward now, basically. So this allows me to see that. But you also probably saw when I zoomed in on a specific node, I could be interested in, where's MailChimp again? Well, it doesn't really matter. I'll just pick somebody else. I'll pick Amy Klobuchar. Her donations have come in 3-4 separate tranches over the course of this time frame that we're looking at. And how does that compare to everything else that we that in our data set? So all the MailChimp donations happened in the same day at the end of June, for example.
Hey, Corey.
Yes.
I have a question from one of our viewers, and I think it's something that in our housekeeping you can kind of just give us, is like, do we have a GitHub repo for examples for this?
I haven't, only because I just really built it in the last week or so. So I haven't put it in a GitHub. Our product, the Keylines, which I'm going to talk about toward the end here, is not open source, but we do have free evaluations. So if you did want to look at this in more detail, you can go to our site, ask for an evaluation, and just reach out to me personally, and I can share this code with you.
Cool. And we'll do all that kind of housekeeping at the end. We got about another 25 minutes. So
yeah, sounds good.
Steve, we'll do what we can to get you more information. Other than that, we're doing great. Thanks. I'll let you get back to it, Corey.
Sure. Okay. So the next thing I wanted to talk about was, okay, so we did learn some interesting things by looking at the broader patterns of all of the data all at once. But what happens when I want to start interacting with it versus beyond just zooming and panning? So a couple of different things. Well, I might want to filter the chart. I've got several thousand nodes on here. It's getting a bit unwieldy. Maybe I want to filter based on value. So if I put this up at, say, $550, so now I've eliminated all of the links in my chart, which are less than that. And so now I'm only looking at the larger size donations. And, there's a lot more isolated ones around the edges, but now I'm looking at the donors who really are giving a lot of money to these candidates. And interestingly, American Express stands out as giving high dollar donations in this cycle. For example, this, Raphael Warnock in Georgia seems to be getting a lot of high dollar donations and so on. So the filtering can be really valuable, and you can filter based on any property that you want. The only property I have that's a number in this case is the actual dollar amount of the donation, but it could be anything. And then the other thing I want to do is I want to search for individual items. So this is kind of the other pattern that I talked about. Let's go search for my personal representative here. Chris Pappas. So we're going to add him to the chart. Now, what just happened was I did that search. It then, as I talked about in the previous slide, it went off, turned that into the correct gremlin, and went off and found Chris Pappas and all of the organizations that contribute to his campaign and brought those back onto the chart. So you can see that here. And now I might say, okay, well, I know some of these, some make sense. They're just his own political action committees, but who's Lav Services in Nevada, and why are they contributing to a candidate in New Hampshire? Well, I can expand out. Now that's just happened again. So it went back out and said, okay, well, now the user wants to see Lav Services and who they're connected to. And, here's some pretty interesting stuff going on. So, they're connected to a mix of Republicans and Democrats, some high value donations, some lower ones. I used the tooltip here so that we can see the detail. That was $288. That one's $10, for example. So then I might say, well, what does he have in common with this Michael McCall person who is in Texas? And now we're really actually starting to drill down into something. Like, this is not, when I built this demo, I had no idea what I was going to find, but I kind of feel like an investigative journalist at this point. Here's 4 organizations with really weird kind of generic sounding names, which are contributing to the same 2 candidates. And if I expand on those, look at this. They are giving the same donations to the same group of 7 candidates on the same dates. So there's something weird going on here. So then I'm actually beyond the scope of a graph database here, but then I started to look up who these organizations were and discovered that there actually was something shady going on. So there was a class action lawsuit that these organizations were doing robocalling, creating a bunch of donations from people and then keeping 90% of them and then just giving a tiny bit to the candidate. So I'd love to say that my demo did that, but actually that was from March. So it happened before my demo, but I did uncover it. So that expand kind of capability is really interesting too, because then you allow the user to sort of guide their exploration through the data, as you just saw me do here. Let's go back to the full data set here. The other thing I talked about was a way to group together nodes. So, I've got a bunch of different candidates here. I've got a bunch of different organizations. I may not necessarily want to see each one individually. I may want to group them together. And the typical way of doing that is by a common property. So in our data set, every member of Congress has a party and a state. So those are the two options basically I have for grouping things together. So let's do it by party first. And now you see what you'd expect to see if you know anything about US politics is I've got, a group of Democrats, and then I've got a bunch of organizations who contribute only to Democrats. I've got a group of Republicans and organizations that contribute only to them, and then a very small number who are in between here. But I can very quickly see who they are. I can select one. Washington National Baseball Club. This is the Major League Baseball team in Washington. So I guess it shouldn't be surprising that, here's the Democrats and here's the Republican that they contribute to. Probably the ones who are in charge of managing DC or something like that. So this grouping can be really powerful too, because it allows me to kind of see broader trends across groups as opposed to the individual nodes themselves. So we can do that by any common property, as I mentioned. So I might choose state. I find this one a little bit less useful because there aren't that many. Here's an example of an organization in Georgia which contributes only to Georgian politicians. But in this case, I didn't find combining by state to give me any new interesting insights. But just as an example of the kinds of things that you might want to allow your users to do in a data set like this. Okay, so what I mentioned, let me lay this out again, is that if we look just at the graph and the drawings here, they really don't give you any sense of when these donations happened. The time bar down here at the bottom is showing me that, my data set happens to cover from January to June, and in general, the amount is rising over time. And the other thing is with the interactivity, I click a node and I can see specifically when that individual or that group of donations occurred, or on a link, for example. But what I don't really get a sense of is like clusters. So I can't say, oh, here's a set of donations that all happened on within a day or two of a different set. If I'm investigating this as a journalist, say, that might be really useful information. Or as a sequence. So if I'm trying to, stereotypically follow the money, I want to know this happened first, then this happened, then this happened. So those two situations call for kind of a different way of thinking about this data. So what I did next was I loaded that into a timeline. So here's one of our tools called Chronograph, which is taking all of those political donations, orienting them by time over a timeline on when they occurred. So that's what we see here. We see our candidates. Let me zoom in on a very specific example here. I'll just pick one kind of at random. Here's one Democratic candidate from California, and here's one donation that they received, and it's superimposed over when it happened, in this case, March 7th. I can zoom out over time and see, okay, well, here they were getting a few other donations from other organizations later in the year. So this is useful because it's telling me sort of, were these things spaced out? Were they all clustered together? I want to find, are Republicans getting more donations certain times of year versus Democrats, or certain states or things like that? The traditional node link representation doesn't really show that to me. And at this heat map view, because the heat map is telling me the density of links in a specific window of time, I see something mildly interesting here. So I see, for example, this line right here in the middle of the screen is pretty solid compared to elsewhere. So April is pretty sparse. There's not much going on in the first 3 weeks of April. But the end of March is very busy. So I might want to zoom in and look specifically at, March 28th has a lot more donations than others. And maybe I want to look at a bit more detail and see who specifically was getting donations on March 28th. And, what else was happening on that date, for example. So what I'm going to do is I'm going to pick a specific representative here to just show you this kinds of situations in which this might be useful. So I was looking for somebody from Texas. Let's see. You can see me scrolling here through all of the, I found Raphael Warnock. I know he's got some stuff associated with him too, actually. So actually Herschel Walker, the other candidate from Georgia, was getting various donations across January, February, March of 2023, and then one more in April. But then if I pick one of those, then I want to focus on that and see, okay, well, where else was this organization donating? And it turns out that they were donating to a bunch of different candidates, but all on the same day, all on this March 28th day. And here they are kind of spread out so I can see specifically what they were. So that's really useful kind of information that you're not getting from the more traditional view. Whereas I can see, this organization donated to this candidate, but not that they all happened within the time span of the same day. Now, it turns out, I did a little bit of research on this too, March 28th was a filing deadline. So you get a lot of donations which happened on that date because they were required to be submitted by that date. So there, you can learn a lot of interesting things also by putting things on the timeline and seeing how sequences and patterns and activity that way. So I think that's it for the demo. What I'm going to do now is just jump out and kind of summarize what we've talked about today. So let's go back to the slides. So here's the kind of the things that I hope that you learn from this. First of all, the structure of the data is where you get benefit from visualization, graph visualization at least. I don't want to give if I have the specific answer, just give the answer. It's more when the user wants to explore, kind of understand the broader patterns associated with my data, where graph visualization might make sense. The second one is to avoid clutter. You saw that I tried to keep my graph as clean as possible, but when a user selects a node or clicks on it, I then have the freedom to give them a bit more detail about that item, because now I only have to decorate that item and add properties to it, not everything else on the chart. You can see that I was sparing with my labels. I didn't give every property I had onto the nodes. I only used the ones that were relevant that the user needed to see about that node at that point. And I didn't use link labels at all. Red links meant they were donations to Republican candidates. Blue links meant Democratic candidates, and gray links were everybody else. I didn't even put a legend because that's just sort of intuitively obvious. I didn't talk about this earlier, but one of the other questions I get from a lot of people is, how do I allow my user to draw new links and put those into the database? And the answer is you can do that. And I have seen it working in some very specific circumstances. But you got to be really careful with that. First of all, like I talked about earlier, the visualization might not have a one-to-one correspondence with how you're storing the data back in your database, especially if you're using a SQL API. And so you're not thinking about it in terms of nodes and links. Which row and column do I actually change when the user creates a new link? Or which property do I change? So that can be a challenge. And that can also be a challenge with security. Do I really want to give my users the ability to edit my source data? And maybe the answer is yes, but most of the times I found that the answer is really no. And then chronograph, if you have data that's changing over time and it's important for the user to be able to understand those patterns in time, then moving beyond the node link representation and showing a timeline or a heat map or something like that can be really helpful as well. And then the last one is that color. In this case, as you saw, I was using the color to represent the parties, can be a really valuable way of showing membership of a group. So I'm coloring them by party. I could color them by state or something like that. I tend not to use sort of scalars on color. The redder something is, the higher value it has for that property, because it's really difficult for the user to understand that. And also to be able to visually intuit which link or which node is redder than the other one, for example. So you can do that, but I tend to shy away from it. All right, that's everything I was going to go through today. So I'm happy to take any questions at this point.
Sure, Corey. We've got one right now. Can you show what kind of data schema this uses in Cosmos? And is it generating SQL in the background?
It's generating Gremlin in the background. And I showed that on the slide here. Let's see. Where? There it is. So basically, it's a very simple schema. It's a one node which represents an organization, one node that represents a candidate, and a link between them which has properties for the value and the date of the donation. And there's a couple other properties. I simplified the gremlin here, but it's basically a couple properties. So it's really 2 node types, 1 edge type, and 2 or 3 properties associated with each one. So I drew that here basically without the properties. But because it's so simple, I mentioned it could be SQL, but in this case, I did choose to use the Gremlin one.
Cool, cool. All right. Well, if we don't have any more questions, we'll wait around just a second. We'll allow you to go ahead and let our viewers know where can they find you if they'd like to ask more questions, learn more about what you're talking about today.
Sure. So the purpose of this was to really show you some concepts. I happen to use our company's tools to create the visualizations, but there's no requirement to do that. The concepts are relevant regardless. But if you are interested in taking a closer look at our tools, then you can go to our website there, which is at the bottom, cambridge-intelligence.com. And if you have any questions specifically for me, you can send those to info@Cambridge Intelligence. I'm on the list that gets that emails to that address too. So I'm happy to respond to anything that might come up after the fact too.
Great, great. And we've got a bunch of our viewers. They say thank you. Really enjoyed your talk today. I know I did too. But now it's time to wrap things up. And before we say goodbye to you, we've got someone to come back and help us say goodbye to our viewers. Askia, welcome back. You're on mute, my buddy. Okay. Seems like he's on mute at the moment.
Sorry. Yeah, I was on mute. I apologize. Yeah, just wanted to say thank you to Corey and thank you, Jay. Excellent information. Hope everybody appreciated it. We do at the Reactor have a survey slide, so we would love to hear your feedback. So feel free. The link is on the screen. And if you need the event code, it is 20025. Love to hear your feedback. And once again, thank you both for excellent information today.
Great, great. Hey, Corey, thanks so much for being part of this today. Really appreciate it. We've got information on how to get in touch with you. We're going to learn more about Cambridge Intelligence and all the stuff that you're doing. Thank you so much. And to our viewers, if you would like to be part of one of these, we would love for you to present as well. There is our intake form down there. Please be part. Anyway, Corey, any parting notes?
I don't think I have any parting notes, but thank you so much for inviting me. I really enjoyed it, and I hope your viewers got something out of it.
Great. Well, everybody, that's it for today. Thank you so much for joining us. We've got another one of these coming in September. We're going to be talking DevOps. DevOps, always still a huge and relevant subject in technology period. We want to automate all the things all the time. But until then, let's go ahead. Let's say goodbye. Thanks for watching, everybody. We'll see you next month. Please let us know that you like the shows. Take that survey. Give the video on YouTube some thumbs up. But until next time, we'll see you. Thanks again.
Thank you.